Okay, everybody, we're going to talk today about linear inequalities in two variables. So what that looks like, typically it tends to look something like this. Ax plus by greater than some c, where a, b, and c are constant numbers. And x and y are variables. Now it doesn't necessarily have to be greater than at this point. Good old focus. That's helpful. Because you could see this as less than, or greater than or equal to, or less than or equal to. But that is typically the form of it there. Now, how we typically talk about these are solutions for this. Values of x and y that make the inequality work. The only real way to show these solutions is graphically, because you could find a lot of different values of x and y that make the inequality work. And to list them all out by hand, to list them as values, would take too long. So we graph. And I'm going to just dive right in and show a few examples of solving linear inequalities in two variables. So I'll start with example 1 off of page 466. And in A, it says graph 2x plus 3y is less than or equal to 6. However, it could just as easily say solve 2x plus 3y less than or equal to 6, or show the solution, get a message, of 2x plus 3y less than or equal to 6. These would all look the same sort of way. Good old autofocus. Well, that's just great. This thing works wonderfully. Give my focus back. Okay. So, any of those statements would mean the same sort of thing, and we end up making a graph of this inequality. So, how do I graph 2x plus 3y is less than or equal to 6? Very similar to how you would graph a straight line. So our first thing is we're going to rearrange this to get y by itself. And we can do all the same sort of operations that we would do to an equation. The one big difference is if you end up multiplying or dividing by a negative, you've got to reverse the sign of the inequality. Although we won't have to do that in this example. So I would start by subtracting 2x from each side. And then I would divide everything by 3. And then I may restate it in a slightly more familiar way. So that is the inequality rearranged that I'm going to try to show. You might notice what we have here looks a lot like the equation for a straight line, with a y-intercept of 0 and 2 and a slope of negative 2/3. So my first stage is going to be to graph the line. Labeling my axes. The y-intercept at 0 and 2. And I'll say this is for the line y equals negative 2/3 x plus 2. Y-intercept is 0 and 2. Slope negative 2/3. So here's my y-intercept. Now a slope of negative 2/3, remember we can think about slope as rise over run. This is 1 unit, this is 1 unit. So a slope of negative 2/3 implies I go down 2 units and over 3 units. I go down 2 units, over 3 units. Down 2 units, over 3 units, and I can go back the same sort of way. Now, before I draw the line in, I take a look at the state of the inequality. Since this is less than or equal to, the equal to part of this means that my boundary line is going to be a solid line. Ideally, you would do this with a ruler. I do not have at me right now. And your boundary line would look something like this. Something like this, although hopefully straighter and better. So we want y values that are less than or equal to negative 2/3 x plus 2. Everywhere along this line, y is equal to negative 2/3 x plus 2. So if I want my y values to be less than that, then I show this region down here by shading. Shading with a pen does not work particularly well. Hopefully that shading shows up dark enough on the film. I believe it is showing up there. So what I have just shown is a region in which every combination of x and y in here satisfies that inequality. So if I picked any point in here, say the point -2, -1, that tells me that an x value of -2 and a y value of -1 would satisfy this inequality. In fact, if I put -2 in for x and -1 in for y, I'd have -4 minus 3 is -7, which is definitely less than or equal to 6. So any point in here would satisfy that inequality. As an aside, I will mention you can also graph these on your graphing calculator. We'll just quickly look at that right now. So if I go to y equals, I'll get rid of these things for now. And if I go over to here, wow, that is way too bright. That's much better. Okay. If I go into my graph and I move over to the far left, hit enter, what it lets me do is adapt what the line setting is. And you'll notice that you can shade above the line or below the line. In this case, since we are less than or equal to, I will stick with below the line, and I'll hit OK. And then I'll just put in what my equation would have been, which was -2/3 x plus 2. And if I graph that, and if I change my window settings to something that is actually useful, give me a moment here. Window. I don't know, on the graph I had over here, I went from something like -5 to 5 with y values of around -4 to 5. And if I graph that, I've got something that looks a lot like the graph I just did on the right. So you can also see what these would look like with your graphing calculator as well, although I won't spend really any more time talking about it there. Okay, so we have done our graph. We have shown our solution for this inequality. Part B of that same example says determine if the point -2 and 4 is part of the solution. Since I have already graphed it, I can show where -2 and 4 is on the graph. And since -2 and 4 is in the unshaded region, so -2 and 4 is not part of the shaded region. Therefore, -2, 4 is not part of the solution. Alternatively, if you want to do a little bit more work, because who doesn't love to do a little bit more work, your original statement was 2x plus 3y has to be less than or equal to 6. If you put -2 in for x and 4 in for y, you get -4 plus 12, which is equal to 8, which is not less than or equal 6. So that would be another way to show that this is not part of the solution. Okay. Another example. Say goodbye to the focus for a little while. This is example 2 of page 468. We are being asked to graph 10x minus 5y is greater than 0. So once again, I'll rearrange that to get y by itself. I will subtract 10x from each side. And then I will divide by negative 5. But note, dividing by a negative reverses the inequality. So, if negative 5y is greater than negative 10x, then 5y is less than positive 10x. Then divide by the 5, and y is less than 2x. And then I can graph that line and show where the inequality, the region is, the solution region. So, if I thought about this as a line, a linear part of it, it'd simply be the line y equals 2x, which has a y-intercept of 0 and a slope of 2. So y-intercept of 0 and a slope of 2, or up 2 over 1. Now, because we are not including the line as part of the solution, because this is not less than or equal to, because it's just less than, I'm going to show the boundary with a dashed line. And the dashed line implies that I am not including the line as part of the solution, just everything above or below it. And in this case, below is what I'm interested in. I have lost focus again. That's really handy. Okay. So, if I want y to be less than 2x, then I'm interested in everything below the line. Really hope this shading is showing up well enough on there. Okay. I should also mention my scales on here. These are 1 and 1 each. Now, if you're not sure which side of your line you should be shading, you can try a test point. And you can really grab anything that's not on the line itself. So let's say I do 4 and 2. So is y less than 2x? And a y value of 2, is that less than 2 times 4? It is, therefore 4 and 2 is part of the solution. Four and 2 is on this side of my line, which means this would be the area that I would shade in. If my inequality didn't hold for the test point, then I would have shaded in the other side of the line. All right. Now, as always, we'll get a chance to work backwards a little bit here. So I'm going to take a look at example 3 on page 469. The picture there will be much better than the one that I'm about to draw, but I will draw it just for the sake of having it out here. We are shown a graph and asked to write down what inequality it represents. if I look closely, I've got a y-intercept here, and looks like my slope is going like that. It's a dashed line. And the region shaded is the region above the line. So, in order to work this out, I'm going to need to figure out what the equation of that dashed line is. And in order to be general, the points you're interested in, you could pick in easily off this graph, but I'm going to leave things a little bit more general and pick out 2 points, neither of which are the y-intercept. So there's 2 points that are on my line. In order to make the equation of a line, there are 2 things I need. I need the slope and the y-intercept. So slope and y-intercept from 2 points. Firstly, my slope. As you have talked about before, slope is a rise over a run, or a change in y value over a change in x value. If I've got 2 points, then I can find the slope by taking the difference in the y values and dividing it by the difference in the x values. It doesn't really matter which one you think of as 0.1 or which one you think of as 0.2, as long as you're consistent in it throughout the calculation. So in this particular case, I could have 6 minus 4, difference in my y values, over 2 minus 1, the difference in my x values. And that's a slope of 2 over 1, or 2. Now the y-intercept, I set up my equation in y equals mx plus b form. Only now I know my slope is 2, since I just worked that out. I know that it has to pass through these 2 points. So I'll work off the first one there, 1 and 4. It doesn't really matter which one I pick. So when x equals 1, y has to equal 4. So 4 equals 2 times 1 plus b. Rearranging that, b has to equal 2. And the equation of my line is y equals 2x plus 2. The slope I put in for my m value, the y-intercept I work out, I put in for my b value, leaving my variables intact. Now, the question isn't asking us for the equation of this line, however, it's asking us for the inequality. So what I'm dealing with is this region above the line I just found, but not including it. That means my y values that I'm interested in are all greater than, but not equal to, 2x plus 2. Now, some may want it in that earlier form that we've seen, and if you rearrange that, that would be the same as negative 2x plus y is greater than 2. Either statement represents that. And now, because what's a math lesson without a word problem? An example of working through a word problem with this. This would be example 4 off page 470. And in it, suppose that you are constructing a tabletop using aluminum and glass. The most that you can spend on materials is $50. Laminated safety glass costs $60 a square meter, and aluminum costs $1.75 a foot. You can choose the dimensions of the table and the amount of each material used. Find all possible combinations of materials sufficient to make the desktop. Okay, so that's probably going to lead us to inequalities. So we're going to need some variables. Since the things that we can use are glass per square meter and aluminum per foot, let's make those a couple of variables. G equals amount of glass used in this construction in square meters, and A is the amount of aluminum used. Feet. A couple of basic statements. The least amount of glass you could use is none. So your G value has to be greater than or equal to 0. Similarly, you can't use less than no aluminum. So your aluminum has to be greater than or equal to 0. Now, the restriction we've got is that we can spend up to $50 on materials. The restriction is where you're going to get your main inequality from. Restriction. Most that can be spent on material is $50. So that means I'm going to need to make some statement about total cost. I know that glass is $60 a square meter. So for every square meter, I'm going to multiply that by 60 to figure out how much I'm spending on glass. And aluminum is $1.75 a foot. I'll have that statement there. This represents cost of glass, and this represents the cost of the aluminum. And what do I know about that total cost? I know that it has to be less than or equal to $50. I will try to get my focus back. Really? Hello, focus. This is a lot of fun. There we go. Focus. Okay. So, now I am down to an inequality, just like we saw before, but with some scary decimals. Now, in this situation, there really isn't any dependent or independent variable per se, so just rearrange for whichever one you find easiest to rearrange for. And I will probably rearrange for A, since that's going to make life a little less painful. So, I will subtract 60G from each side. And then I will divide by 1.75. Since I'm not dividing by any negatives, I don't need to worry about things that way. And what I get is unpleasant numbers, but there we have it. Actually, I should follow your textbook's example. They just leave things in terms of fractions. Although, I will probably show the decimal equivalents here in a second. Alright, and now to graph this thing. So, scale is going to be important here. Also, labeling my axes are going to be important here. So A is taking the place of my y values, G is taking the place of my x values. My A intercept is at about 28.6, and my slope is a relatively large negative number, negative 34.3. So, if I go up by tens in aluminum every 2 units, and if I go over by 1 for every 4 units should be plenty, I think. About that actually. Oh, I don't even need to go that far. 1, 2. Okay. That's enough of a scale to let me draw this. How did I pick this out? I knew that my A-intercept was going to be 28.6. And that my slope is negative 34.3. So every 1 unit I go over, I'm dropping by 34.3 units in the other axis. Should make it so you can see that part there. Right, so let's draw this thing with approximation. So at about 28.6, you're around here. And for every 1 unit I go over, I go down about 34.3. So 34.3 would have me down to here, and then another almost 6 units down. Which would take me down to about here. That's not a lot to work on, but it's enough for us to draw a straight line. Oh, I really wish I had a ruler here somewhere. Oh well. Straight edge of a box. Win in a pinch. Now you might notice that I've stopped at the axes, and that's because of that other those other statements that I've made. My G values all have to be greater than or equal to 0. My A values all have to be greater than or equal to 0. But my A values have to be less than or equal to everything on this line. So my solution set is everything in here. Right, and there it is. So what this graph shows is all of the possible combinations of amount of glass and amount of aluminum that you could use to make this particular tabletop and keep your costs to less than or equal to $50. Alright, that is about all that I have to say about that. Again, while we sort out how things are working with school, I can't assign work, but if anybody would like to have some reference for practice, there are a few things that you can try. That would include things like questions 1 to 9, 11 to 13, and 15 from pages 472 to 474. Right, that's it for now. Good luck out there, everybody. Stay safe.